So we're going to only cover trapezoids due to kind of our snow days, and kite is actually just an additional standard we could add in if we wanted to, but it is not required. But basically, if you want to know about kites, kites are the diagonals are perpendicular and they have exactly one pair of opposite angles that are congruent. So then you can kind of figure out from there using Pythagorean theorem different sides and then different angles for kites. But we're going to go ahead and move to properties of trapezoids because we do need to cover those. And a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of a trapezoid are the bases of the trapezoid. So this would be considered the base, and this right here would be considered the base. So for each of the bases of a trapezoid, there is a pair of base angles, which are the two angles that have the base as a side. The non-parallel sides of a trapezoid are called legs. If the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. The mid-segment of a trapezoid is the segment that connects the midpoints of its legs. So let's go ahead and take a look at three properties of trapezoids here on the next page. If a trapezoid is isosceles, then each pair of base angles are congruent. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. A trapezoid is an isosceles if and only if it is diagonals, if its diagonals are congruent. So let's go ahead and draw a little picture to kind of help us here for our isosceles trapezoid C, D, E, F. And we know that CE, so that's actually this little diagonal here, is 10. And we know that angle E is 95 degrees. So it wants us to find DF and the measure of angle C, which is actually going to be the same as D, and we know that those are going to be supplementary. So we could go ahead and take 180 minus 95, and we know that's 85. So if this D is 85, then so is C. So 85 equals the measure of angle C, which also equals the measure of angle D. And then F would have to be the same as this base angle. So the measure of angle F is equal to the measure of angle E, which is 95 degrees. And then our last little part that it's asking for is DF. So DF is going to be that diagonal, which is going to be the same as this diagonal, so 10. On the next part here, we want to figure out what the measure of angle A is. So if we know this is 100, then we know this is 100. So there's 200, and we know the total is 360. So 360 minus 200 leaves us with 160, and then splitting between A and B, divide it by 2, that would mean this is 80 and this is 80. So measure of angle A, 80 degrees. Here, KB, this segment right here, is 21.9. MF, the whole diagonal there, is 32.7. And so what would the short part be? Well, it's going to be the same as this short part. And we can find that short part by subtracting the 21.9 from this, because those diagonals are going to be the same. So 32.7 minus 21.9 is going to give us 10.8. So that's going to be 10.8. FB is going to be 10.8. On this last example here on page 20, we have these two angles, which we know are going to be equal to each other because they are both up here. And so they are kind of considered base angles together, and we know those are congruent. So 2a squared minus 54 is equal to a squared plus 27. So we're subtracting a squared, and that gives us a squared minus 54 equals 27. We're going to add 54. So a squared is equal to 81, and then we want to square root to get just a. A is 9, or plus or minus 9 since we do the square root. It could be negative as well as positive. Page 21, at the top here, we are given AD, which is this diagonal, and BC, this diagonal. The diagonals are equal, so we can go ahead and set 12x minus 11 equal to 9x minus 2 and solve. 3x minus 11 equals negative 2, add 11. So 3x is equal to 9, which means x is equal to 3. And it wanted us to just find x, so we are done. Next, we're given base angles here of an isosceles, so these are congruent. So go ahead and set those equal and solve, and you can check when you're ready. So solving, hopefully you got plus or minus 4 for C. So we're going to lastly talk about the mid-segment theorem. So that is when we have the midpoint, and we have a segment through the middle there. So we know that xy is equal to half of the sum of both of those bases, so BC plus AD. When we add up the bases, divide by 2, we get the mid-segment. So we're going to find the mid-segment here. So we're going to add the 8, add the 10, and divide by 2. So half of 18, that would be 9 inches. So the mid-segment here, add 10, add 16, and divide by 2. So 26 divided by 2, that would be 13. Right, try the next one on your own, and then check and see when you're ready. Hopefully you got 10.75. And then on the last one, we're actually given the mid-segment, so we are going to set it equal, whoops, that should be 25, not 12, to 25 plus EH. So we can go ahead and undo the half. You can either distribute it, or you can undo it by multiplying both sides by 2, and that is a little bit easier. Then we can just go ahead and subtract 25. So EH should be 8. And then if you wanted to review some special quadrilaterals, here, basically, kite, parallelogram, trapezoid. Parallelogram can be a rhombus or a rectangle, and then a rhombus could be a square, and a rectangle leading to a square as well. So what quadrilateral meets the conditions where we have at least 2 congruent consecutive sides? A kite, a square or a rhombus. And then for joining our midpoints of the sides of an isosceles trapezoid in what special quadrilateral is formed and why? Well, a rhombus is formed. And then if you wanted to try this one and graph it, looking and seeing, I will post kind of the answers for this part and scroll through them so that you can kind of try it and review and then see if you're on the right track. All right, so on this one, we have that the diagonals are perpendicular. We have that the sides are parallel. We have that these sides are parallel as well, or perpendicular, so that forms all right angles. So this actually proves that it's a rhombus then, using all of those, and that the diagonals are congruent as well. So then on this page here, there's those examples if you wanted to check your work for those. Kite, again, you're not responsible for right now, but this one, square and Y, think about what would make something a square. And then here's kind of how they all fall in. Kite's kind of on its own. Trapezoid, we could have isosceles. Parallelogram, we have a rectangle and a rhombus, and when it is both, it is a square.